1. Litmus test for homemade cryogenic engine. GS Paper 3, Science and Technology. What is the context about? Riding high on 2 previous successful GSLV flights powered by indigenously developed engine, India's cryogenic technology will go through another litmus test when it propels a GSLV rocket with one of the heaviest satellites in the INSAT, GSAT series on Thursday evening. GSLV is a 3-stage launch vehicle and a cryogenic engine is used in the third or upper stage. GSLV FO5, INSAT 3DR. GSLV FO5 is the 10th flight of India's Geosynchronous Satellite Launch Vehicle, GSLV. In this flight, GSLV will launch 2,211 kg INSAT 3DR, an advanced weather satellite into a geostationary transfer orbit, GTO. INSAT 3DR will provide a variety of meteorological services to the country. GSLV is designed to inject 2 to 2.5-ton class of satellites into GTO. A 2,211 kg INSAT 3DR, an advanced weather satellite, will take off on board GSLV FO5 from the Sriharikota spaceport. What are cryogenic engines? Cryogenic engines use liquid hydrogen as fuel and liquid oxygen as oxidizer to burn the fuel. It can produce 1.5 times the thrust compared to conventional liquid rocket engines. Hence, it is used in the third or upper stage of a launch to place heavier payloads. Cryogenic stage is more efficient and provides more thrust for every kilogram of propellant it burns compared to solid and earth-storable liquid propellant rocket stages. The principle behind cryogenic engine. The principle behind cryogenic engine is to liquefy both oxygen and hydrogen fuel at very low temperatures, so as to increase the quantity of fuel available during the flight. The mixture of oxidizer and fuel at low temperatures are allowed to expand, and gases are allowed to pass through the convergent-divergent nozzle, as shown in figure. This helps in getting the necessary thrust to the rocket, required to move out of Earth's blanket. Why did India start thinking of developing indigenous cryogenic engine? In January 1991, Soviet space agency Roscosmos reached an agreement with ISRO to supply cryogenic engine and transfer its technology. However, US claimed that the cryogenic engines could be used to launch missiles and therefore under the provisions of Missile Technology Control Regime, MTCR, it stopped Russia from transferring the cryogenic technology. Russia has agreed to supply cryogenic engine but not the technology. Thus, India initiated a program to have its indigenous cryogenic engine. Significance of indigenously developed cryogenic engine to India. Cryogenic engines are a critical requirement for the success of India's GSLV program as it seeks to place about 2,500 to 3,000 kilograms communication geosynchronous satellites in geostationary orbit. It makes India independent in launching satellites heavier than 2 tons and help other countries too in achieving the same, making it a source of revenue too. Why the success of cryogenic engine test matters most for India. ISRO's success in mastering cryogenic technology is important for the following reasons. With the development of the INSAT-2 series of communication satellites, which weigh more than 2 tons, India felt the need for launch vehicle that would be bigger, lighter and more efficient than its workhorse PSLV. Earlier India sought an assistance from foreign space organizations such as European Space Agency for placing satellites weighing more than 2 tons in geostationary orbit. This involved considerable costs for the exchequer. Seeking assistance from foreign agencies was also not desirable from a strategic point of view. India's ambitious space programs such as missions to Moon and Venus in the near future will not be possible without rockets fitted with cryogenic engines. Timeline. After a decade of development and flawless tests, the maiden developmental flight of the Indigenous engine conducted on April 15, 2010 did not succeed. Critical modifications were made to the engine and the rocket before its first successful flight in 2014 and in 2015. Indigenous cryogenic upper stage was successfully flight tested on board GSLV-D5 launch vehicle on January 5, 2014 from Satish Dhawan Space Center. In this successful flight of GSLV-D5, a communication satellite, GSAT-14, was launched very precisely to its intended geosynchronous transfer orbit. Geosynchronous Satellite Launch Vehicle, GSLV. GSLV was primarily developed to launch INSAT class of satellites into geosynchronous transfer orbits. GSLV is being used for launching GSAT series of satellites. GSLV is a 3-stage launcher that uses one solid rocket motor stage, one Earth-storable liquid stage and one cryogenic stage. The flight of GSLV, the GSLV-D5, placed GSAT-14 into its planned orbit and marked the first successful flight of the indigenous cryogenic stage. Earlier, GSLV had launched various communication satellites, among which EduSat is notable, being India's first satellite built exclusively to serve the educational sector through satellite-based distance education. What is a geosynchronous transfer orbit or geostationary transfer orbit? A geostationary equatorial orbit, GEO, is a circular geosynchronous orbit in the plane of the Earth's equator with a radius of approximately 42,164 kilometers, measured from the center of the Earth. A satellite in such an orbit is at an altitude of approximately 35,786 kilometers above mean sea level. A geosynchronous orbit, GEO, takes a satellite around the Earth at a rate of once per day, keeping it roughly in the same area over the ground. A geostationary orbit, GSO, is a geosynchronous orbit with an inclination of 0, meaning it lies on the equator. All geostationary satellites are geosynchronous. Not all geosynchronous satellites are geostationary. What is the low Earth orbit? Low Earth orbit is just above the atmosphere, 165 kilometers to about 2000 kilometers. In fact, it's still in the atmosphere, and spacecraft placed here will slow down and re-enter within days, weeks or months if not continually boosted. We put things in LEO because it takes less energy to get there. LEO carries a spacecraft around the Earth every 80 to 120 minutes or so. Disadvantage of LEO. The first is that there is still some atmospheric drag. As a result, over time these objects slow down and their orbits slowly decay. Simply put, the satellite or spacecraft slows down and this allows the influence of gravity to pull the object towards the Earth. Highly elliptical orbits. A highly elliptical orbit, HEO, is an elliptic orbit with a low altitude, often under 1000 km per g, and a high altitude, often over 35,786 kilometers apogee. The highly elliptical term refers to the shape of the ellipse, and to the eccentricity of the orbit, not to the high apogee altitude. Why HEO are so special? Such extremely elongated orbits have the advantage of long dwell times at a point in the sky during the approach to, and descent from, apogee. Visibility near apogee can exceed 12 hours of dwell at apogee with a much shorter and faster moving perigee phase. Bodies moving through the long apogee dwell can appear still in the sky to the ground when the orbit is at the right inclination, where the angular velocity of the orbit in the equatorial plane closely matches the rotation of the surface beneath. This makes these elliptical orbits useful for communications satellites,